First thing I'm going to start off with is how climate models are actually, what are they and how they're actually represented. They're really just a scary amount of mathematics. And here's what a graphical or a representation graphically of a very, very simple model, which has the globe. Here's Perth sitting here in Australia, set up into what looks like a sort of a 300 or 400 kilometre grid perhaps. And then we've got perhaps 6 layers of atmosphere coming up out from that model representing the atmosphere of the world. That's a really, really coarse model because there's so much going on you could imagine within these squares that the model isn't actually representing. So mathematically what's happening in here is represented by some equations in terms of air movement, of temperature, of density, of moisture content, and just all obeying the laws of physics in terms of hot air rising, moisture, colder air descending, stuff like that, scary stuff. And then of course we do have the ocean as well. So here's just a representation of a much more complex model of a higher resolution. I think this one must be the UK Met Office because it's situated over Greenwich. And we've got something like 12 layers of atmosphere above there and something like 15 layers of ocean underneath. And so earlier models were this kind of simplistic, but models these days now have up to sort of 28 levels of atmosphere above and something like 30 levels of ocean below. But still, they're not, they're only just representing what's going on in the world because of the resolution of how big those squares are. So here's an output from the Bureau of Meteorology's POAMA 2 model, the current operational model. It has a 250 kilometre grid around the world, and you can see that for Tasmania that equals half of 4 squares is what represents Tasmania. 12 to 13 squares represents Victoria. So there's no way that accurately represents the world. We're well aware of that. But mathematically, and the sort of computer you need to go finer than that, it was unobtainable or not purchasable or too expensive up until now for the Bureau. So the thing we have with this kind of resolution is that you'll see the Bureau's forecasts come out and they'll be much smoother lines. You won't see that kind of graininess. They use some statistical sort of abilities to make the forecast look more accurate than what it is. So it's important to understand that, so this is the forecast for July in 2010, looking forward to August, September, October, the big wet El Niño. And it's got a prediction there showing that the southwest quarter of Victoria is more likely to be average when everything around it is looking much wetter. And so due to the resolution of the model, I would pose the question of, do you believe that? Because I wouldn't, even though that's what it says. And of course, what happened was that it was wet everywhere. This is just looking at topography. So topography plays a really important part in Australia's climate, as it does all around the world, because mountains cause climate system or weather systems to lift, which allows them to rain. And so we have many features of highness around Australia. If you've never flown in an aeroplane, you really don't realise how high things are out here in the centre. So this is the POAMA model's representation of topography in 250 kilometre square grids, and it's pretty pox. Like, it's just, you can see the Hamersley and McDonald Musgrave ranges up here, but that'd have you believe that was the only high point in Australia. Access S is the new model that the Bureau is working on. They've pulled it straight from the UK Met Office, then they're going to Australianise it, and it's got a resolution of 60 kilometres, so much finer, but there you've got, what's that, four times the resolution, so 4 times the computer grunt required, and that's what's happening with the new computer and this new model. So you can see that much better resolution of things like the King Leopold Range, the Atherton Tablelands, the New England tablelands, and even the Western Tiers in Tasmania now appear in this model, whereas before they really never did. So one part of accuracy or improvement in accuracy is actually better resolving the real world that the models are actually seeing. Here's just a representation of average August rainfall across Australia, just showing how that resolution really improves things. This is Poama at 250k, this is 60 kilometres of access. This is the real resolution in much finer resolution just in terms of August rainfall. This is not a prediction, this is just showing what August rainfall has historically been. And you can see that, not surprisingly, 60k much more closely represents that than that. So the Bureau's got their new big Cray supercomputer. It's there, it's operational to an extent at the moment, but still in the process of getting it to go. These are sort of figures that mean absolutely nothing to a computer nerd like me because they're just hard to understand. So 16 quadrillion calculations a second, 50,000 processors, so 60,000 or 50,000 of your own laptops sitting there grunting away, worth 77 million and costing 12 million a year to run. Most of that I think is probably electricity. So one thing about computer accuracy is actual improvements in resolution and computer power. The next one is how easily you can parameterize your model before you run it as to what the current state of the world is. And so what's interesting is that at the moment we have a greater ability to represent the world, or we've got better data coming in about what the world looks like right now than we have for a model to actually represent it going forward. And this is because we have fantastic data streams coming in. So these are Argo buoys. Here's me hugging one. They're worth about $10,000 each. And everywhere you see a dot on that map, there was one of those floating in January. And once a week, they sink to the bottom of the ocean, they come up to the top, and they take salinity and temperature readings, zap that off to the satellites, and then they also track their drift pattern as well. So since the advent of these, we've had unprecedented information about the ocean to depth and ocean currents. And the green ones are all the US ones, and the pink frog's eggs are all the Australian ones. We're the second biggest hitter in terms of these Argo buoys around the world because the ocean plays a really massive part in climate around Australia. So every 3 days, the information from those Argo buoys comes in. We have a heap of fixed buoys going up and down through the Pacific. We've now got underwater drones that you let go at the side of the beach and you remotely control, set them, and they take off into the middle of the Pacific and turn around and come back, and you pick them up at the beach again, download them. And so you can see, here's a map, you can see some of these drone deployments going through these areas here with these straight lines. But all that data comes through from all those cross points and gets crunched every 3 days to form maps of the undersea of the ocean. What happens above the ocean, of course, in terms of temperature of the ocean, comes in primarily from satellite information, which is fantastic because you see this is the modest satellite here, that with just a couple of runs a day of that, you don't get 100% coverage of the world always, but it's pretty easy to extrapolate and fill in the gaps. These are the buoys through the middle of the Pacific, the Triton array, which, you know, they've got the 2-ton blocks on the bottom of them, and they're going up every day, taking information along the equator through the Pacific. And we also have the Ships of Opportunity program. If you want to give someone something to do on a ship going from Perth across to Saudi Arabia, give them $50 or something to take the temperature every hour. They will do that because they're bored out of their mind. And so we've got marvellous information on the world's shipping routes about ocean, both to depth and also at the surface. So that stuff comes in every 3 days as well. Then we have other weather phenomena like wind, and I've often wondered how satellites could possibly do wind. It's something you can't see. You can see cloud, yes, but you can't see wind. This is a different satellite, the ASCAT satellite. This is a scatterometer, and that scatterometer is the thing that does height. So it's the thing that's doing height in your paddocks, very accurate. And when it does height across the ocean, it's picking up wave height very accurately, and wave height very closely represents wind speed at this ocean surface. So incredible wind speeds down here in the Southern Ocean, and no joy to be down here in a sailboat because the wave height is enormous. But you can see once again, it's not perfect and it gets all sort of merged together, but you can see that the resolution of this is way better even than 60 kilometre grids. So there's great skill in taking these data sets in every day, hourly in some respects, and merging that into the data that can initialise the model when it runs forward for 3 to 6 months. So we've had great, marvellous improvements in data acquisition to initialise the models. The models are getting better in terms of their resolution. The other problem we've got really is just the way the world works in terms of what times of the year do the various phenomena that some of these models are trying to predict actually affect our rainfall. So this is for North Central and the North East. It's not very different from the Wimmera and the Mallee in the southwest. East Gippsland, it's very different. But here we have, through the months of May to October, most of the climate drivers we look at have their greatest effect during our growing season. There's not much effect over summer, and then we've got the dreaded predictability barrier in autumn, where we most want to know what's going on, where the models, not so much the models, but the world has no skill at sort of predicting rainfall at that time from these major climate drivers because they're in reset mode. They're doing, from what they were in spring and summer of last year, they're now reverting back to normal, and at this time of the year they haven't made their mind up as to what they're going to do for the coming season. And so even for a computer to work that out, that is pretty difficult, where historically there is no real correlation at that time of the year. So for models to work at that time, they've got to have a much better representative of the much local influences around Australia in terms of pressure and frontal systems, ocean temperatures, and how they are potentially affecting the weather and the climate when these things here are potentially giving them no signals whatsoever. The fourth thing that's important is the actual skill of the model. And so all the world's agencies that are doing this modelling, they build a model and then they test their model on how it has gone historically. So they have what's called hindcasts. So they initialise their model for all these years and months, maybe going back 20, 30 years, and they run the model, and then they bring up maps of what they called skill, of where the model's actually done particularly well at predicting the climate that happened in the past. So this is POAMA 2. These are their hindcast skill maps for summer, autumn, winter and spring. You can see it's summer. There's a bit of medium skill through Victoria and through much of WA. We get into autumn and it's pretty pox over most of the country. Go into winter and southern Queensland, northern New South Wales is in action, but Victoria's going nowhere. And in spring, much of the eastern half of the country is looking good. And if you come from Rockhampton, well, you're really in business because you actually have high skill, but you're the only place in the whole of Australia that does for spring. So you can find areas of this map, not perhaps where much is going on, but north of the Bight, where there's no skill of this model at any time of the year. So this is reality. Every place in the world has these issues, but they're all mathematically trying to improve these maps of skill. So what's important is that when you're looking at a prediction for climate, it is important to know what the skill is for your model at that time of the year so that you can go, should I be ignoring this or should I be really taking notice? Complex graphs here. Quite simply, what we're looking at here is the progression of 3 different versions of the POAMA Bureau model from sort of 8, 5 and 3 years ago. In green, blue and red's the most recent one. Let's not worry about the statistics. The closer you're getting to this grey line, the more skill you've got. And so what we can see is that for rainfall and temperature is that the POAMA model had been slowly getting better and particularly with the last iteration of POAMA 2M here, but not so much for minimum temperature, but certainly for those other parameters, that model has been getting better. which leads us to the fact that, as I alluded to, the POEMA model's being kicked out. It's quite an old model. It's probably 3 generations ago, that model. And since then, there's been better ways of representing the ocean and the atmosphere and the way they join together. And so the Bureau's in a collaborative arrangement with the UK Met Office, grabbing their GLOC5 model, and then over time, they're going to parameterise that with Australian features to make it better for Australia. But the good thing is that this model, so this is the ability to measure the Nino 3 temperature in the middle of the Pacific, is that POEMA is down here, and this is what the correlation is between how skillful it is at getting it 1, 2 and 3, 4 months in advance. And you can clearly see that the Access model there does a much better job than our current model of doing that. And the other thing is in terms of predicting, this one's Nino 3.4, so the middle of the Pacific Ocean. In terms of predicting that, GLOC is much better in its skill rate at all times of the year than what POEMA is. So that's a really good thing. We're going to a model that's at least better at getting some of that right. Importantly, is it any better at getting rainfall right? So this is the August, September, October forecast from POEMA and for Access historically for both rainfall, maximum and minimum temperature. Let's not worry about the stats, but the redder you are, the more skill you've got. And if you're blue, you've got no skill at all, negative skill in fact. So you can see here POEMA for Victoria for spring, for, you know, it's in the middle, it's not too bad, but you can see that Access is a clear improvement in both rainfall and maximum temperature in particular over much larger areas of Australia than the current POEMA model. And quite selfishly, there are vast improvements for Victoria. Now, speaking to the Bureau yesterday, and quite excitingly, the Access model, for some reason, has greater skill than certainly POEMA in that critical autumn period. So it actually has some skill as opposed to none. So we look forward to the bringing on of this, which we're led to believe is sometime in the last half of this year. I might move on. So looking back historically how models have performed, these are my own fast break analyses assessments that come out in the email for the last 9 years. And this time we're looking where the predicteds are. This is the vibe of the prediction from 11 or 12 models. So not just looking at one, but a number of them. And the really good thing is that in terms of predicting Nino 3.4 temperature in the middle of the Pacific, which is where El Nino and La Nina happen, the models are pretty good at doing that. And thank God for that, because that's the main thing these models have been worked out to do. So, you know, there's really good skill there, and quite a number. 2012, an El Nino was predicted, but it didn't happen. And in 2016, a lot of them were still on this La Nina horse, but that didn't happen either. So it's kind of got the good rating. But pretty good effort in the Pacific Ocean. Unfortunately for the Indian Ocean, we fall down. The problem is that for the Indian Ocean, Australia is about the only country that really cares what happens in the Indian Ocean. The others couldn't give a hang. So no one's spending vast amounts of information as to how what happens in the Indian Ocean affects Australia, because there's no vested interest in that. So Australia's doing a lot of work at the moment to try and get better Indian Ocean mathematics, and they'll be included in subsequent versions of the new model. So we can see there that some of the IOD positives and one of the IOD negatives have been picked out, but often we're getting these IOD positives happen where there's, you know, not a really good signal. So there's one here and another one here. So it's probably the odd model getting it there, but the vast majority haven't, so you don't know which way to jump. This is my entry in the worst slide of the day, I think. 27th of July in 2010, this is the fast break prediction for rainfall, and circled in pink are the wetter forecasts. So we had a really strong La Nina, but we still didn't have every model lighting up going, yes, it looks like it's going to be wetter. We had an average to slightly wetter prediction there, and the poor old BOM's seasonal forecast, the old statistical system, actually had some drier signal of all the crazy things when no one else was saying that. So for rainfall, it's a bit of a cracked record. Often the models are getting, well, they're getting some part of Victoria right all the time, but they're getting some bits wrong as well. So 2008 right through, last year they had a purple patch. So 2010, that slightly wetter to average signal. It was wet, so I've given it a rating of good. Last year they all had a slightly wetter signal in July for August, September, October, and tick, 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 that's in fact what happened. There was a really good signal there. I've often wondered though, well, I've not wondered, I haven't wondered enough. I've looked at this data more recently and noticed, quite scarily, that when half the models start to deviate away from average, that has really often happened. So half the models here saying slightly drier in 2008, it was drier. 2009, that was a neutral kind of year. It was predicted to be drier than it was, although there were some parts of Victoria that were quite dry. 2010, a slightly wetter signal from half the models, and it was. 2011, another neutral year that turned out slightly drier, but no one thought it would be. 2012, slightly drier from half the models, and it was. The same for 2014 and 2015, and last year they got it right as well. So this is quite a scary thing for me when you look at the repeatability of this, where half the models change, and that's enough to say there's something probably going on here. And I suppose you need to think that if half the models are predicting something different from the neutral kind of position sitting on the fence, there's probably something going on in the ocean or the atmosphere to suggest that that is going to change things. So, I've only done this for July, looking to August, September, October, where the most skill is. It would be interesting to have a look at how this goes for previous months, but then I may need one of those computers that the Bureau's got to do that. 5 minutes, beautiful, rightio. Temperature, really poor show there for temperature. And I don't really know why. Generally, temperature is easier to predict as weather than rainfall, but climate seems to be harder. And perhaps it doesn't really make a lot of difference to us because there's not a lot we can do about predictions of warmer temperatures actually affecting what we do in the field. But very few years where they've actually got that perfectly right. So what I've showed is computer grunt getting better resolution. I've showed better parameterisation of the models, and I've showed models getting better skill, particularly at the times where the correlations are best. The next thing is, how are people using these models, and are they part of the solution and or the problem? And I'd say they were. This is 6 years of data from the fast break readership from 2007 to 16, asking them for a number of different tools, what sort of rating they're putting on the use of that. And the BOM seasonal forecast has jumped from sort of 33% up to 66%. So since 2007, a doubling of the importance put on that model, which is kind of good because back here I wouldn't have given it a bar of soap for the way it was. People using decile information, yield profit, soil moisture ranks very highly, thank goodness. The SOI perhaps getting more credence that it deserves, but I'm happy to talk about that later. And what I'm excited about is sea surface temperatures, because our team is about the only one in Australia or Victoria that's really been talking about that. So to go from 10% to 40% of people looking at sea surface temperature maps, I can pretty much mark that down for stuff that our team's been resultant for. What are people doing with these forecasts? We asked them. So we asked farmers, what are they doing with the forecast? They're doing a lot of obvious things like changing irrigation, nitrogen, purchasing feed, hay and silage adjustments, changing stock. And then we have the major thing they're doing is scarily changing their sowing plans and their crop types at the time where the models and history has got the worst skill. And that worries me. I know everyone wants information at that time of the year, but the models, sadly, are not the place to be looking with any confidence. Are the agronomists any better? Well, they're marginally better, but there's still a fair few of them, a quarter of them that we polled making decisions as to sowing plans and crop types from climate information, but much more of the obvious ones like nitrogen and just having a chat with it around the campfire. So the critical thing, I think, is to understand when these models have skill and when they don't. So this is the most recent fast break analysis, and I'm now going to include, at long last, a line about the skill of the model for the time period that we're looking at. There's only one model there from NASA which is reporting high skill in autumn, which is actually hard to believe, but anyway, that's what they're quoting. We have 3 models here predicting a weak El Nino in the next 3 months, which is interesting given that we have seen no evidence of one at the moment, nothing much happening in the Indian Ocean, and sort of half these models have got slightly drier tendencies for the next 3 months and warmer as well. The real interesting stuff is how these models are all seeing the progression into the middle of the year to winter, and damn it all if they're not all jumping on the El Nino horse, which is really bizarre because as we don't have an El Nino at the moment, what are these things doing? Are they on drugs? What are they seeing? And they're also predicting drier ones as well. There's even a few snips of ID positive which often go with El Nino. And so it's really only a really warm patch in the Pacific Ocean off Papua New Guinea that the models can all see, and if we get reverse trade winds to push that under the sea, we could get an El Nino kicked off. And we also have some warm oceans starting off on the South American coast, which could also kick the it won't kick the El Nino off, but it won't help. But unless those trade winds reverse around Papua New Guinea, there will be no El Nino, and we currently don't see that happening at all. So, but nonetheless, they're all jumping on, which is scary because this is too early for them to be making any skillful prediction to do that. In 2014, it looked a bit like this, and the El Nino didn't happen, but an IOD positive tooled us up in spring. In 2015, they were like this, and it was an El Nino and an IOD positive. In 2016, it looked like this at this time of the year, saying La Nina, and we didn't have a La Nina, but we had an ID negative, it was wet anyway. And so we get to this year, and they're all saying El Nino quite early on, and you're going, well, can I believe that? Should I be remotely worried? And I would say, too early to tell at this time of the year. So it's interesting, but until we start seeing those reverse trade winds, I'd be ignoring it. So that's it. And happy to take some questions if there are any.